The branch of science that takes into account the two behaviors, the dual behavior of matter and the uncertainty principle, is the quantum mechanics. I can tell quantum mechanics is a theoretical science that deals with the study of the motion of the microscopic objects that have both the observable wave-like properties and particle-like properties. Now we get a question. Can we apply quantum mechanics to macroscopic particles? Yes, of course, we can apply quantum mechanics. Quantum mechanics, when it is applied to the macroscopic objects, the results obtained are same as that of the application of classical mechanics for the macroscopic objects. Quantum mechanics was developed independently by Werner Heisenberg and Erwin Schrödinger. A mathematical equation that explains the behavior of electron is termed as Schrödinger wave equation. By solving the Schrödinger wave equation, we get a wave function and energy of electron. The wave function psi in the Schrödinger wave equation represents atomic orbital. What are orbitals? Orbitals are the 3D space around the nucleus where there is a maximum probability of finding an electron. A large number of orbitals are possible in an atom. These orbitals can be distinguished by their size, shape and orientation. An orbital is smaller size. It means that there is more chance of finding electron near the nucleus. If an orbital is of bigger size, the probability of finding electron would be much lesser, or it is much away from the nucleus. Similarly, shape and orientation, it means that there is more probability of finding the electron along a particular direction than along some other directions. Atomic orbitals are identified or differentiated by knowing their quantum numbers. What are these quantum numbers? We will discuss about the quantum numbers in a while. Where do I live? I can tell the location where I live just by telling you my address. Similarly, where an electron is present around the nucleus is told by quantum numbers. In simple, I can tell quantum numbers give address of an electron around a nucleus. There are 4 different quantum numbers. Principal quantum number, which is represented by small letter English alphabet N. Azimuthal quantum number, represented by L. Magnetic quantum number, represented by ML. Fourth is spin quantum number, represented by MS. In order to tell my location, I need to tell you in which state I am living, which district do I belong to. Under the district, I should be specifying which particular taluk or the colony I am living. Similarly, principal quantum number that represents shells where the electrons are present, that is similar to that of the states according to our address. Azimuthal quantum numbers can be taken similar to that of districts. For an electron, it represents subshells, and the magnetic quantum number represents orbitals of the electron, which can be compared very similar to the taluks or colonies when we consider the address of our living. Principal quantum number is represented by n. N is a positive integer with the value of n is equal to 1, 2, 3, so on. Principal quantum number determines the size and energy of the orbital. It identifies the shell to which an electron belongs. The number of orbitals in a particular shell is given by n square. N is equal to 1 represents K shell. Similarly, n is equal to 2 represents L shell. N is equal to 3 represents M shell, and n is equal to 4 represents n shell and so on. Azimuthal quantum number is represented by L. It is also known as orbital angular momentum quantum number or subsidiary quantum number. It tells us about the subshells. It defines the three-dimensional shape of an orbital. For a given value of n, L varies from 0 to n minus 1. That is, for a given value of n, the possible values of L are 0, 1, 2, so on till n minus 1. For example, when n is equal to 1, the value of L is only 0. For n is equal to 2, the possible values of L can be 0 and 1. Similarly, for n is equal to 3, the possible values of L are 0, 1 and 2. This continues in a similar manner. The number of subshells in a principal shell is equal to the value of n. For n is equal to 1, there is only one subshell which corresponds to L is equal to 0. For n is equal to 2, there are two subshells, L is equal to 0 and 1. L is equal to 0 represents S subshell, L is equal to 1 represents P subshell, L is equal to 2 is D subshell and L is equal to 3 represents F subshell and so on. The magnetic quantum number is represented by ML. It tells about the orientation of the orbital. ML can have values from minus L to plus L. The total of 2L plus 1 values are possible. For L is equal to 0, ML is equal to 0. It means only one orbital is present in S subshell. For L is equal to 1, ML is minus 1, 0, plus 1 tells that 3 orbitals is present in P subshell, that is Px, Py and Pz. Similarly, for L is equal to 2, ML is minus 2, minus 1, 0, plus 1, plus 2. 5 orbitals in D subshell, that is dxy, dyz, dzx, dx square minus y square and dz square. It's important to remember that each orbital can accommodate maximum of only 2 electrons. To sum up, S subshell has 1 orbital, P subshell has 3 orbitals, D subshell has 5 orbitals, F subshell has 7 orbitals, G subshell has 9 orbitals, H subshell has 11 orbitals. Spin quantum number is represented by Ms. Just now I have told that each orbital can accommodate 2 electrons. These 2 electrons have 2 types of motion. One is rotation about the nucleus. Second, rotation about its own axis. For example, you can consider the rotation of Earth around the Sun, and Earth rotates around its own axis. Similarly, the electrons here. If one electron is rotating in clockwise direction, the other will be rotating in anti-clockwise direction. The two orientations of electrons is one is upspin and the other is downspin. The electron with upspin has ms value of plus 1 by 2 and an electron with low spin will have the value of ms as minus 1 by 2. It's important to note that 2 electrons present in an orbital can have same values for n, l and ml, but their spin quantum number is different. The 4 different quantum numbers can be summarized using this particular table. Now let us summarize the different quantum numbers. Here we shall list the different shells, the corresponding value of principal quantum number and the value of L corresponding to the azimuthal quantum number. L can have values from 0 to n minus 1. Also we shall list magnetic quantum number which varies from minus L to plus L. We shall also write the subshell notation corresponding to the different quantum numbers. Also, we shall write the total number of electrons that's possible for each shell. So the total number of electrons is given by 2n square. To begin with, we will start with K shell. The corresponding principal quantum number is 1 and the azimuthal quantum number can take values from 0 to n minus 1. So the L value is 0. The corresponding ML value will be 0. So the subshell notation here is S and it is corresponding to the principal quantum number 1. So it is 1s. Coming to the total number of electrons. It is given by 2n square and the n value is 1 here. So 2 into 1 square. So total number of electrons is 2. L shell corresponding n value is 2. So the L can take values 0 and 1. Corresponding ML value is 0, plus 1, 0 and minus 1. So corresponding to the ML value 0, the notation is yes and it is corresponding to the shell 2, L shell, so it is 2s. And the ML values corresponding to plus 1, 0, minus 1 is represented as 2p. The total number of electrons, it can be calculated as 2 into 2 square, which is 2 into 4, it is equal to 8 electrons. M shell has the principal quantum number value as 3. So the corresponding L values is 0, 1 and 2. ML values is written as 0, plus 1, 0, minus 1, plus 2, plus 1, 0, minus 1, minus 2. The subshell notations corresponding to L is equal to 0. It is yes. Corresponding to L is equal to 1, it is P. And corresponding to L is equal to 3, it is D. So since they belong to M shell, it is 3s, 3p and 3d. Calculation of total number of electrons, it is 2n square, n value is 3, it is 2 into 3 square, which is equal to 2 into 9 and total electrons is 18. Considering N shell, the value of N is 4. Corresponding L values are 0, 1, 2 and 3. ML values for 0 it is 0, for 1 it's plus 1, 0, minus 1. For 2 it is plus 2, plus 1, 0, minus 1, minus 2. For 3 it's plus 3, plus 2, plus 1, 0, minus 1, minus 2, minus 3. L value corresponding to 0 is yes, for 1 it is P, for 3 it is D and for 4 is F. So these subshells are belonging to the shell number 4. So it is 4s, 4p, 4d and 4f. Total number of electrons is given by 2n square, n is 4, so it is 2 into 4 square, it's 2 into 16 and the total number of electrons is 32. So this table summarizes the values for different quantum numbers belonging to K, L, M and N shell. And this is in the same way we can continue for the other shells also.